Sir, I think we can start our session. I will be giving brief description of who sir is. Krishna sir, currently pursuing PhD at TU Graz, Austria. His research centers on artificial intelligence for interspecies communication. He holds his MTech degree in CS in cybersecurity from Central University of Punjab and BTech in IT from Maulana Abdul Kalam Azad University of Technology, Kolkata. Sir is a seasoned trainer and educator, having conducted high impact workshops and training programs in collaboration with renowned institutions. These include a 5-day IoT fundamental training of Wipro L1 engineers and Can summer workshop on blockchain technology, IoT and smart city systems at premium institutes like IITs, NITs, and Triple IT. He has also been invited as guest lecturer at TU Graz and Hochschule in Austria and as a speaker for Atal Faculty Development Program. Sir, extensive experience in research and development, particularly in IoT, security, and blockchain application, underscores his leadership and in technology demo. His passion lies in leveraging cutting-edge technology to solve real-world challenges, bridging the gap between academia and industry, and contributing to a sustainable and innovative future. So, sir, handing over to you for further session. Uh, Sir, I think your mic is on mute.
Oh, sorry. Yeah, thank you so much for this brief introduction and having me here. It's a really great honor to be connect with that again, once again, like faculty development programs and the participant who's from India. It's very hard. Usually in the early days, we are taking that physical workshop mode, and it is quite engaging and all. But now the things, everything is remotely, and after obviously the COVID, it is a great option. So we can worldwide, we can connect and we can give the practical based approach on the online system. So basically today is also more on the talk about blockchain, IoT, and more exciting journey, whatever we done that so far. I'm going to share the all knowledge, insights, and some technical details. Then I hope you will enjoy the session. So without any delay, I just want to quickly start share my screen, and I'm just switching off my video so I can save my bandwidth so my voice will be more clear and screen will not blurred for you. So that's it. Thank you so much. And now I'm going to show, I need a system preferences for this. Oh, sorry for little delay. Actually, usually in the Mac, there is a lot of security things. Okay, now I believe you are able to see my screen. Just tell me that yes or no. If it is fine, then we can start here.
No, sir, your screen is not shared.
Not shared it. Actually, I did that sharing option, but I'm just, I don't know why. Okay, let me try once again. So share open systems. Everything looks good. Mhm. Usually it works, but I don't know what's happened. So should I rejoin or because it's asking that grant access system preferences and allowed already, but still it's not giving permission to share this screen. Maybe I will try to do once again. Once again. Oh, sorry, there is some turbulence here. So let me, okay, let me rejoin once again. Sorry.
Okay, sir. Okay. Yes, sir. We are able to see your screen now. Sir, we are able to see your screen now. Sir, I think your mic is on mute.
Is it okay now?
Yes, sir. Yes, sir. It is working fine.
Oh, okay. I hope my voice is clear enough and loud. So I'm just starting now my presentation. So first, what I'm going to talk about today is most on that practical side about the blockchain, Internet of Things, and we'll deep dive in the technical sides like how we can create the decentralized application, how IoT works, and other stuff. So for that, I know that this total entire session is based on the healthcare, and we have also very cool demonstration about that healthcare sector, how we can as a role or as a developer in the blockchain and Internet of Things, how we can make some build the society there. We can like fearless, we can do the transactions, we can do the we can do provide the services, we can trace all the records without any manipulations and in the secure manner. And you know that in the IoT, because there is a lots of networking stuff is there, like we need a end-to-end security in that, then combination of the blockchain and IoT is a giving the main like combination that. So blockchain is providing security and IoT using providing the, and IoT is providing the automation stuff, so it is giving the full fledged like problem solver application for real-time issues. So I'm just a little bit brief about our journey, like Addition IoT Solutions. We started in 2021 from Bangalore, and after that now it's a Europe-based company, and we also doing some R&D projects with the help of Austrian government, FFG, and all those things. So we are also engaging in the AI, IoT, AI ML stuffs, and also we are more concerning a project that is one of that ocean forum. There is a one we are doing the marine life species innovations, like how we can observe that. We are helping to the biologists, teachers, and innovators who is doing the research with help of IoT, obviously. So this is the totally background about my all the research what's going on. And now I'm just through this block diagram, I want to going to explain what exactly today we are going to talk about the whole sessions, what we are going to show about that, how blockchains work, what the cloud it is, IoT cloud, how to set the sensors on the controllers, how to send the data on the cloud, and how you can make the decentralized application with the help of blockchain. So so let's ready for this first part, that what we are going to cover, that is basically the cloud and the hardware Raspberry Pi. After that, I will come to the blockchain, because I believe you have already the fundamentals and theoretical concepts related to blockchain. So I will touch all the components, but if it is already covered, then you can just tell me, okay, sir, you can just unmute your mic, or you can say, okay, we already covered. And so we can immediately skip these things, and we can continue uh, to the next onwards, the tool sets. Okay, so here we are not only going to talk about blockchain and IoT, as well as also we are going to talk about the AI/ML, like how generative AI can give the prediction on the age-based, and this will also give some type of a suggestions. What is the your heart rate monitoring system? If like you have a sensor of this pulse sensors, if you have a heart rate data sensors, then it can give that your health opinions, what you should to do and all. So you can see everything in the demos and later on. Second side, you can see if you can check here. Let me just setting my platform. So what we have to do today, so IoT cloud. So in this cloud you can see there is a many clouds are there. In the Amazon Web Services we have a clouded, Azure, ThinkSpeak, UB Dots, and many more, right? So here, but the problem is that in the Amazon Web Service and in Azure, if you are going to give some cloud information, then the problem is that we need a credit card. And again, you of guys, some of them they have, might be someone is a student, then it's hard to create the account in this platform. So that's usually then I prefer that always that use the ThinkSpeak, because concept is always same. So only we have to understand that how we need to do the integration with the hardware and the software, right? So in the cloud, so here we can use the APIs, we can use different types of read and write methodology, like through the MQTT, or might be through HTTP protocols. So it can communicate through the REST. Then you can ask that, okay, if we already cloud, then what is the role of the blockchain technology? Definitely there is a like a very major role of the blockchain technology, because this is going to be provide the decentralized application, and this is cloud is going to provide the central applications, right? So here I will show you that also through the demonstration and through the applications, how it's storing the Ethereum inside the Ethereum block, how we can trace all the blocks, like and how it's connected with the hashes, right? So that will be the good for you. So make some visual appealing, like how that node is creating to the each other. And other side, obviously decentralized. So that is a good combination. So if you have some sensitive information, you want to trace those information in the blockchain, because blockchain obviously for transaction, if you can see, that is we need to do the mining, and it's a cost effective because we did the encryption, and there is a lots of power consumption is needed for do the transactions for one transactions. So we have to choose, we need to do the as per the application requirement, exactly what you want, which data should be traceable, which data should be centralized, which should be the automation, and all those things. If you know those things, then you can create a wonderful applications for your real-time scenarios. Okay, why I choose the Raspberry Pi? One of the reason is that because here you will get the VNC your connection. So if in during the session, if you want to create something, and I can give you the access, or a little bit, it might be you can also add your any accounts, and you can send the data to your cloud system. So that is the one of the reason. Okay, so I hope this is clear for you. So this is the basically understanding what is the fundamental. I hope you know that decentralized ledger, what is that? I'm believing you know that immutable records, how is it, like creating the transactions in the cryptographically linked, and how it's a temper proofed. So this theoretical concept, I believe you know that. So if you will, I am like you are not getting anything, or you miss something during this, then just ping me that, so I will give and elaborate that, and you will get better understanding about the demonstration. Okay, so now I'm moving to this two visual demo. That is very important, and because I just want to just make one stat, like how much you are understanding about this technology. Okay, so let me just open this one, and let me show that how the blockchain series works. So I will just take 5 minute time to set your stack, and after that I will move to the demonstration of the. Okay, so where is the Google Chrome? Here I just want to paste this. Okay, it's not copied at all. Okay, let me scan. Okay, P. Let me see this. Okay, so now let's go in this. So I know that because you have the proper structure. I'm just giving a little bit the visual appealing how the blockchain is works here. So here you can see this in this block. This is the block is created first block, and if you are changing any data, then it is generating the new hash, and this is the connected with the previous hash. And once you will mine it, then your data is stored, and now so you can see this is the entire block is denied with the other blocks. So same like that, if you will do or try to tamper any data, then its entire block will be denied by the peers. So it will tell, okay, this is not authenticate. Automatically, it will be removed from the peers. And you can see this is the previous hash and this is generated hash. So each and every hash is connected with the other hash. So if you do any changes, then it is not matched with your previous hash. That is the reason it's a denying. And you can see this is the red one. And other sides, you can see this, if you can save, basically what we are doing in this blockchain, we are saving the data. It can be a values, it can be a crypto, it can be anything, right? So here I'm just telling any messages. Hello, Christian. So here is a message. And after that, we can do the style, or like, mining of this process. Again, click it. Hello, yeah, and so same thing, mine that. And after that, you can see once you will start the mining, then all entire is you have to approve it, then it is connected to the all of the hash. So you can see this hash value and this hash value is connected, and this is the link. So this is just like visual appealing. So how blockchain is works, I believe everything is clear now. Now I'm coming on the distributed. So this is suppose like a peer one. This is you have a one system. There is a somewhere in the decentralized like a peer B. There is a second system is there, and peer C. There's a third system, and after that it going to like connected to each other. And here if you say some data, then it will be denied by the all the things. Okay, so this is the same concept related for the tokens. If you want to share some data, so we have one demo also that we are going to show like how we can do the trading in the healthcare equipment in the global wise. That I will also invite to the Prabhakar. He can show you that, my colleague. So we can see those things later. So you can see if we can change any values, any amount of that, then you have to do the mining, and after that it will be connected with the other blockchains. Is it clear? Yeah, meanwhile, if you have any questions or something, might be you can just put some reactions, then I can understand, okay, everything is fine, going good. Okay, then good. Then now I'm coming to the next part, that is security, how it's become like a secure this demonstration, like what is the private key, public key, because this is important part for my this demonstration. So I'm just giving you the little bit the background. So what is the private key, what is the public key? So you can see this is the random generated, and just for the visualization purpose. So if it will create the private key, so accordingly it is also changing the public key value. So private key is basically you can store this value in with your own, because this is your secret key, and this public key it will go with the data. So through like a hash value, you can send this account address, okay, send me this cryptocurrency on this my account. So basically that's a type of a public key. Signature, what we can do, like we can do type any messages like hello, and we can do the signature of your private key, and once you sign, then it is creating the massive signature, and it is like in encrypted has with the hashing is done. That once you have to do the verify, then you have to verify with your signature, and then it will ensure that, okay, this is now green color, so message is not tampered or something. If you put some, then it is changed, and you can see this message is now tempered and it is not verified. Okay, so this is basically the concept of the public key, private key, signature, and all those things. Second demonstration is related if something you want to send one person to other person from to this address, some money. Just take the example, I want to send some $10 rupees to the with the private key. Then we have to sign with my private key, and after that you will get this massive signature, and you have to verify by them. And I want to do, no, I don't want in, I just did something changes, and you can see this is tempered. And once I will do the same value 10, then it will be. I believe this demo you will like it. And yeah, if you have any questions, any doubts, to not getting this public key, private key concept, then you can ask me, or I can move forward. Okay. So let me see if you have any questions. No questions. That's all going good. Means perfect. So I'm moving now to the next, why blockchain and IoT is important, and then after that, I will show you that one of the very popular demo that is usually we are doing, and I know that because most of the audience here who is aware about the blockchain but not aware about the cloud IoT sensors. I'm assuming because I saw that there isn't there is nothing, so I will go it slow. But yeah, if it go like looks like I'm going very slow, then just tell me, okay, I can speed up. And if you're already aware about that, then I can, jump into the next one. Okay, so this is the why blockchain for IoT data actually, because it can be provide security that I already told about that. Faster data change, so you can ensure the data authenticity, source of the destination, who is sending this data and all. So because in the healthcare sector is very important, just take the or like organ donations, like who is giving donating your organs, who is main donor of this, because there is a lots of scam is also happening, there is a lots of problems, this the organ trafficking and all. So that is the reason I think this application can be very useful to control such type of suspicious activities, and obviously the lower costing and operating cost, because everything is automated with the help of IoT. Okay, so now its work is blockchain and tools. Here the sudo pip install Ethereum JSON RPC. You can install there, and after that, this is connecting with your Ethereum in this block diagram. You can see here in this, and after that, it is connecting to the MetaMask. So whatever the history you are creating, like you are storing some information, then it will be generated inside the Ethereum blockchain, and after that, it is creating the chain, and you can trace the public ledgers also. So this is the one of the library that is needed for this. I will show that once I will remotely connect my kit, and I can do that. Okay, so now I'm going to switch my presentation to my board here. Let me share my screen of any disk. Let me see this. So okay, share screen. So Google Cast, this name is Chrome Remote Desktop. This one I was looking for. And now what I'm going, everything is actually connected with my Raspberry Pi, and it is live now. So, and now I'm going to connect with the VNC viewer, so you can also see on my screen what is going on. So now I'm going to connect with the desktop, Christian, and pin we have to give. Okay, I believe now you are able to see my screen here. So this is just what I did the coding earlier. So just let me minimize this. And here is one code. And this is my real VNC. If you don't know about the real VNC, then I'm just quickly explaining that real VNC viewer is remotely access. You can take that from your Raspberry Pi in the locally you can connect, and they are basically connected to the SSH. So it is like, through your IP address, they are communicating, and you can see there the GUI screen also, not only the command based, also you can see the screen, and you can do whatever in the globally. So this is the one of the controller view. And here, now you can see this in this VNC viewer. This is my screen. So, okay, and now I just want to show my setup, how it looks like currently. And once it is Good, then I will show that what is connected right now. So here we can see this is the okay, so we have to just put one command that is so I can show the camera ff play /dev and /video 0, and I hope it will screen this video and you can see my setup here. Good. So I'm just trying to do a little bit bigger so you can visualize properly. Might be camera screen is not too good, but not bad because this is just external camera. So I put it that to visualize. So here you can see this is the basically the sensors, temperature sensors, light sensor, ultrasonic, gas sensor, and everything is here. One side you can see the Raspberry Pi that is connected. So here Raspberry Pi will send the data through this whatever the temperature and humidity sensor, it will process and it will send the data on the cloud. So my first job to show you that how the data we can send on the cloud, and the firstly we will show in this console. Second examples we have that is based on this Arduino Uno. Might be you can see in my hand, it is one of the Uno board is here in the parallelly. So in this Uno board, you can see this is the temperature and humidity sensors I connected. Let me this. Okay, so this is the temperature and humidity sensors that is connected with the Arduino Uno. And here we are going to print the temperature and humidity data, and I'm going to explain the code, how it's going to work out. So let's see this Arduino code. And this is the LDR sensor. Okay. Okay, why it's not opening? Minimize. Let me try once again. Okay, minimize it. So this is file. Okay, so now we can see this, the temperature and humidity value by this code. Let me flash this. So this is the Arduino editor IDE. So here you can you can write the code in the C++ and you can see. So this is the define like a pin. This is the GPIO4 I'm using this, and this is the DHT11 sensors that I'm using. So I defined here, and you can see this is the loop continuously. It is working on the 115200 serial port communications. We are doing that SSID password for the sending the data and all. So here you can set your password and you can set your network. So it is capable to send the data through, because Arduino Nano have a inbuilt there is a Wi-Fi, so you don't need to do anything. It can be able to communicate with that. So second, okay. So now you can see done uploading. So all this code is flashed over Arduino Nano. And here you can see this is the value of the humidity temperature. We defined it, and it will also calculate in the Fahrenheit. So now it's a delay. We given the 2 seconds, and every time it will display the serial print, humidity value, and temperature value. So just for the displaying, I am showing this all the things. So payload, if right now sending the data on the cloud, it's actually we are just testing purpose. We did that, but right now server is not on, so it will not able to send the data on the cloud. But yes, we can see on the console like a value and everything. So you will get the idea how the sensors will work on the console side. Okay, so here let me go tool and serial monitor. So okay, fail to that is expected because cloud is not connected with that particular port and it's not open. So here you can see this is the 91 humidity is showing that, and if I will blow the air or something, then in this temperature, then it will also increase the temperature. So this is the real-time value. We are just taking from my sensor, and with the help of controller, this is Arduino Nano. Okay, now you can see this is the increased value and humidity, because while vaporizing with the mouth, there is a lots of moisture containers, so it is also increased like a 95%. So more or less, it's not much accurate, but it's a DHT11, just like a generic sensor for the testing. Why I'm explaining this thing? So it will help me to, once I will show the last demo, if how to connect the pulse sensors, ECG sensors, and how we can send this data to not only the cloud as well as in the blockchain. So this is the normal connection setup. I'm just giving that how the things is work, but you can connect any types of sensors similarly with the help of the GPIO pins. It might be a digital sensors, might be the analog sensors, or different types of sensor you can connect. So it's not mandatory like you can just go with the AIoT development kit. You can choose any controller like Raspberry Pi, Arduino, or anything. So it will work with the cloud. So it's depend to the limitations of the board also, and what is your application, what you want to achieve the demonstration. That's also matter. Then according to that, you have to choose your controller, sensors, and all. Is it clear? So any questions so far? So now we are able to see that here my data, temperature, and humidity can display in this local. It's still cloud is not connected. Now I'm coming to the how to connect the cloud. But till now, any questions, any sensor related, controller related, anything? Just giving me, just I'm giving you 10, 20 seconds. Just analyze, think about it and tell me. Do you have any questions? So I'm just going to quickly see in the chat. If someone have any questions, then we can ask it. Can discuss there. Okay. No questions. Means I believe everything is going good, because obviously this is all the basics and all. So I believe you know all about this. Okay, now I'm just going to open about the ThingSpeak. So how to connect this data to the cloud. Good, good. So now let me open my browser. Not here. I want to work in this my remote desktop itself. That would be better. So let me open my ThingSpeak account. So how many of you know about that? What is the ThingSpeak? ThingSpeak Cloud, have you worked earlier? Anything? Yeah, you can just put in the chat, So if you already know that, then I will not go through the brief. If you don't know, then little bit I will go in depth and I will tell how it's work and what are the working functionalities. Okay. So we have, just say in the chat box, that is fine for me. Nope. Okay. You guess you don't know about that. Never worked. Any of other participant who worked earlier, who worked earlier, who worked earlier on this type of things, ThingSpeak or any other clouds? Okay. So I got response. If you don't work, then I will go a little bit more depth in this, and let's see. Okay, good. So ThingSpeak is a cloud that is basically created by mostly the open sources. It's like you don't need to pay anything. That's why it's a very favorite for the academics people and for the students to develop their prototype. Now, question is that how it's work. So in like a background, there is is working with the MATLAB, and they are doing all lots of like a math works and all analytics. You can do it. You can see the data. You can visualize those data. You can generate alert systems. So this is like central authorities there. You can see everything what's going on in your a smart home, a smart hospital, or might be a smart healthcare center. So all the live data you can see here. So for that, how to create the account is creating the account is quite like you need. academic email ID. That is one of the things. And once you will create that, then it will display something like this. And this is the ThingSpeak. Okay. So let's see. This is the channels. You can see this, and after that, you can create something like account. You can sign out, and again you can log in. So already I did that, so it's better to show what things. So messages is available is giving something like how much messages you can send, like so we have this much limit, you will get it. And it's also limitation because this is for the demonstration purpose. So you can't create multiple channels. Like a channels, what is the meaning of the channels? Channels is like if you want to create some application like a smart city, then in the channels there are multiple field will be there. Then just take the example, you are going to create some smart building monitoring system or a smart health building monitoring system, right? So every room you want some feedback or the real life data. What is the environment surroundings? What is the CO2 level? What is the temperature of the room? What are the, so this type of parameter if you want, then just tell that okay, channel one is like a room one, and channel other channel is like a room two, room three, and so on. You can create multiple channels. So total channels you can create 4. That is the one of that. And fields you can create 4 or 5. There is a one limit is there. Okay. Here you can do the email alerts. Still allowed 800 emails. You can do that. And still I did not use anyone because just demonstration purpose. I just created for this account because earlier account was not working for me. So I just newly created this one. Clear? Now very important. So this is all about this ThingSpeak, how it's work. Now the second one, I'm just going to talk about the connections, that is API keys, and how it's going to work. So here, this is my profile. And in this profiles, you can see this is I used one of the institute email ID. And here you can see this is my user API key and this is my alert API key. So if you want to create any alert system, then you can use something, you can generate here in API key and you can generate the alerts also, might be in your email or somewhere, or Slack or WhatsApp or whatever. Okay, so this is the whole concept. Now I'm coming to the channels. I'm more explore that how it's work. So here I'm going to show that how we can say I just used because temperature already used for you. I saw that. Now I'm moving to the one other flavor, that is a light sensor that is based on the board that just now what I displayed you before on like on the camera, right? The same one, and it's connected. Everything is done. So in this channel, light sensor, what is our goal is I want to send that light value, light intensity value, like a 0 or 1, something will be happen, then it will send the data on the cloud. So yesterday I tested, for I just want to be like everything is working. So you can see this is data is working. But how the things is work, I am going to show into it, like how to write the code on the Python or Python script, Raspberry Pi and all. And after that, I will run this script and you can see this is how to connect this API on the script and how it can able to send the data. It's quite easy. Means parallelly, if we want to create the account quickly and if you already created, then we can immediately, I can use your API keys and I can send the data on your cloud. So if you have a time parallelly, if you have a fast enough, then you can follow me. Okay, otherwise I will share these all details. No worries. So just main perspective of this workshop is to understand the full end-to-end application, how the concept is built, and you have many more resources, right? You will get it nowadays. There is a lots of AI tools and things there. They will guide you much better. They will provide you much information. But here you have to understand the flow, how the things is working, and how we can design some applications with help of blockchain, IoT, and controller and sensors, right? Great. For the public view, we are using you can share this in the public, but till now I have access only the private. I don't want to share my data in the public. So this is the things channel I used like a light sensor. I just created the channel settings name here. So light sensor, I given the name, and field name, I given the LDR. Might be channel name. If you have some ideas like, okay, I want to monitor about some hospital, all the buildings blocks, what are the temperature is there, what are the CO2 level, because the patient need some specific certain conditions, then it is good for their health, right? So in that situations also might be you can create something room 1, room 2, room 3, and every room you can use this field numbers, like what are the parameters value you want to set it out here. So field 1, field 2, you can just click like this, you can give some values, and that's all. Okay, so field 1, field 2, field 3, field 4, so till field 8 you can, means total 8 properties you can get it out, all the values and all. Okay, so now after that, we have to share, like, email ID. If you want to share something, that keep channel view private, or if you want to share that, then through this users you can add it. That is one of the best sharing channels. View IR, like, you want to give some access to the other persons. Okay, you can also, like, some admin persons who can see your all the dashboard and all those things, then you can give the access. API keys. So here you can write the API keys like this. So write API key is nothing but if you have to write the data to the cloud from your microcontroller, then you have to use the write key API, write API key. Okay, clear? Write API key, what is that? If you have to send some data to your cloud, means whatever the means in ThinkSpeak cloud, then you need a write API key. If you want to take some information from like your Raspberry Pi, then you need read API key. Means just take the example, something happened, like, temperature sensor is increased 38 degrees Celsius or certain temperature, a certain threshold value. Then in that case, what we need is we need to perform some action. Okay, turn on AC, turn off AC, or whatever this type of, or might be something, some other actions you can perform it, right? So you can use this read API key. So once it will read like, okay, temperature is reached something, then after that it will control something. So it is cloud connected activities can be also there, or through the cloud also you can control your devices, like, you can control your room services. So if you are sitting in California or you are sitting in some in the corner like South Korea, no matters, anywhere you can control your all the entire building infrastructure, it is in your hand. So that is basically the how IoT we are working that, right? All about the automation. Great. Other features that is one of the very important, like, you can import and export all the data, and you can do some types of predict analytics. Might be you have, if you know about that, Google Colab and all, you can create some models. I'm just giving the example of the one of the scenario of the Delhi environment, right? So if suppose take the example, every year CO2 level is increasing, every year temperature is increasing, then we can do the future forecast, right? We can do the prediction next 5 year what the temperature is going to be happen as per the past 20-year data sets or 100 data sets, right? So this data is, that's why very important. We can do many types of predictions, we can do the analytics, we can observe those data, and after that, on those observations we can take lots of actions, like we can take some greenery, or might be plantation system, even and odd, like, cars should not go that is type of initiative. So we can reduce the carbon emissions, we can reduce the CO2 levels, we can reduce the temperature as per this initiative. So these are the help for the prepare ourselves for the future. Clear? Any questions, any doubts related to ThinkSpeak so far? Okay, so if you don't have any issues, then I'm moving to the now hardware side. I'm moving to the VNC viewer, like, I will connect my Raspberry Pi controller, and I will show the Python console, what you have to write the code, how to write the code, what are the libraries needed for that, and so on. Is it clear? Okay, I'm going back to the question set. So I just want to see if you have any questions or not. So no questions. Shall I move? Just say yes, then yes. Any one of you just say me, then I will feel it's going good. Perfect. Thank you, Yogesh. Okay, now I'm moving to the next one, that is cloud side. So again, coming back on the VNC viewer, here is my VNC, real VNC is there. Wow, perfect. So my video is stuck because sometimes camera is not much is screen time is delayed, so that is one of the reason. But sometimes it work fine actually. But you saw my setup, right? So here is also my just a Nano board is there. If you in the corner you can see this, and I have a Raspberry Pi. I have Arduino, so everything is this in my lab. Okay, good. So I'm just going to disconnect this camera. I think you already understood everything is here. Now I want to close this. It's stuck actually. Uh-huh. Yes. Let me see if I want to close this. Close the. Good. So now I'm out. Now I want to show how to send the data. Now my next goal is to send the data on the cloud, right? Okay. So this is my first LDR temperature sensors and data. Not this. Let me open once again. I think it's not here. File, or might be I will go on the Thony. I think it should be here. It's quite delayed because I'm taking the remote access, so it's quite slow. But if you'll work with directly to your system, if you'll connect with the like your desktop and directly connect with the mouse, it's quite faster. Okay, so this is my one of the code that is in the Python script. This is a basic code. Just I'm giving the flavor like how the things is work here. And after that, if you are using some other sensors, then might be they need some specific library. Then at that time you have to do a little bit research on it. So here I'm using LDR sensor. Just my goal is to send the data, and I can show you how like a end-to-end connection is working, establishing here. So this is my base URL about the API thingispec.com, and just update the data. And this is my API key. Do you remember that this API key? Yes, this is the same API key what I shown earlier for the writing on the database on the cloud, right? This is the same writing API key. So here I used a light sensor. This is the GPIO pin number is 33. I use that because the internally board is connected here with this GPIO 33. Okay, in the request, because this library we are using to sending the data for posting the request on the cloud. So this is the library we are using, GPIO, just for the general purpose input output pin library. So it's connecting with your which pin you are connected to sending the data. So that is responsible for that. Import time, I use this library for times, delays, second, fractions, how frequent data you want to send on your cloud. Sometimes it's needed to be like a very frequent data, but if sometimes if you need don't need if after 1 hour frequency it is also fine, then you can set it out in the bottom here through this library. This is a two condition state. There is a two types of LDR sensor is there. There is one is analog sensor. They will give the precise value how much light intensity it is, and second is just like if it will light will come, then it will give 0 1. If it is no light is there, then it's 0, like 0 1 step. So that's the very simple and quick information about this. So here once we are sending this data on the cloud, then you can see this is the response request.get. So this code is responsible to sending the data on this through my API. Field one is you do remember my field name is that field one, and this is the light state I just given. So light state, what is that? This is the variable name what I given there. So light status is 0, then it will send the value 0. If light status is 1, then it will send the value 1. Okay, good. Any questions? So here time sleep I given the 15 seconds time. So every 15 seconds it will upload the data on the cloud, and after that it will clean up the GPIO. So I don't want to reserve this. So once it will program will execute or I will terminate, then parallelly it will be clean up all the GPUs. So it is no need to be override. Clear. Okay, good. So now I'm moving to the next without any delay. So this is simple code. I think it is not very tough programming also. This is just a simple. Only you have to understand how to send it. This is the main part to connect this, and this GPIO and all those things. It take time to be practice if you are new, but it's not very hard. It's a Python based and it's easy script to write the code actually. Good. Now I'm just turning on this code, and you can see this is the light detected, and send the thing speak on the response 0. Okay, so light detected, then now I want to see this data. Is it really sent or not? So let me go in my channels. And this is my light sensor. And you can see this is the value just now printed here. So in my current time in Austria, it's 11:16 and it's taking my system timing. So it's showing that 11:16 GMT. Okay. Okay, and now once I will put the hand on the light sensors, then it is should be okay. So you can change. You can see this is the changing is happening. Okay, so once I will remove again, then again it will go down. So it will. You can see the zigzag of the. So just imagine that now you created some other field variables before the visualizations, not the LDR or something. Might be you can just use want to use for the healthcare sector ECG sensors. Then you can see all the graphs of the ECGs, like the one you can monitor online all the conditions of your patients. Also, not only this, but also you can do like a CO2 environment and other pulse sensors values continuously. You will get the pulse data of your person, diabetes, glucose, diabetes sensors. So this type of things is just an idea. It's building your thoughts how we can connect these things and how it's going to be work. I believe this is useful for you, and it will help you to build the bigger demonstration that what I'm going to. So this is the small modules that we are trying to achieve. Good. So any questions? Any type of questions? Anything related to this? Because I went very slow, I think it is more sufficient to understood everything. So we have other type of gas sensor. So in this board, what just now I saw in the image, so this board is basically have a gas sensors, ultrasonic sensor, and so this is just built for the to create the prototype models, and after that we can create for the research and development we can do some analysis of the data. Okay, now I'm going back to the sys. You can see now light detected because I just given, and it will send this things. So once you will refresh this applications, you can see that. So it will send that. Yeah, see up and down again. It's going up so slowly. Anyway, I think this is fine. Perfect. Nothing very much things to do. Any questions? Let me see once again. Perfect. So any questions so far? Okay, then I'm going back to my slide here. So next, what is my goal to achieve? Perfect. Not this. Or this. This one. And now we can see this board. Okay, now you understood the cloud about that, how the clouds work and everything. So these are the few demonstrations. This is very popular demonstration. So might be now you can correlate after this demonstration. You can correlate that how the real world application we can develop it. We like different types of use cases. Just take example of the supply chain traceability. Just take the example. Lots of medicines we need that to be maintain some certain temperature, some certain conditions. Then otherwise that medicine will be not useful. That drugs will be exploit, right? So it's a again, and that is a huge loss. So how we can maintain such type of environment? Then we can where is all the chain we can do the tracing. Okay, it's like a deliver from the vendor to consumer, what are the things, what container they use, what are the conditions of the container, what are the temperature size, what are the outside conditions, is a winter also. So even not only those, also the expiry labels and everything you can mention in this chain. This use case only, I'm not talking about the IoT. I also think about in this blockchain side. So we can trace everything by using the blockchain, and automation stuffs can do by the IoT devices. Is it clear? Next, we are talking about the smart healthcare in the secure patient data, because data, patient data is very important, because there is a lots of time you heard about that. There is a, if we can breach some communication, or take like man in the middle attack, or any types of attack will happen, or any DOS attack, so you can jam your device itself with the pinging lots of IP addresses. Then that side of the big loss of the human life, right? So it can be a risk of the life actually. So in this case, we need to be provide into insecurity, so no one can tamper those data, those information. No one can misuse those information by to your clients or your patients, right? So that is a one of the use case you can create by using this. Smart cities, you can create like administration, one of the administration, a smart street lighting, a smart garbage collections, and a environmental monitoring system, each and everything, because these are the small models of the smart cities. So you can interconnect everything, and you can create build the big applications, including smart hospitals and other infrastructures as well as smart industries. Like there is lots of people want like robotic hand. We are talking about that smart warehouses, how we can control that, certain climates of that particular areas. So warehouses also needed some chemical industries, needed some particular chemical equations, like if it will mismatch, then it will be big like some problems can be arise, and it can be a reason of the blast or some bombarding inside that, because of that wrong combinations of the chemicals, right? So that is the one of the also reason. So you can use these devices to be automated and everything, so it should be very precise. There is no chances to do any human errors. So these are the use cases, and now I believe you can connect yourself by you see this demo how the thing. So I'm just giving the example, smart environmental monitoring, and definitely I think that now you guys is able to create that smart environmental monitoring system. So here we use that air quality sensors, here we use the temperature and humidity sensors, gas sensors, and you can send the data on the Raspberry Pi, Arduino, or whatever the controller. Here is just to the boards, but you can do that one, and you can send those data to the mobile applications, your web applications, your smartwatch, or whatever, and you can create this to into on in between. About this blockchain later, because we are just framing that IoT concept right now. Once you will frame fully the IoT concept, then I will tell that what is the role, how we can plug your blockchain, and how it is sending the data. I will come later on this one. Okay, now I'm coming to the next one, that is a smart waste management system. You can see this already implemented in the one of this California. There is a one of the dustbin. We just set the ultrasonic sensor, so it is just says, you can see this is the 95% is empty, 86. So as per the distance, it's measuring all those things. Clear? And this is the data. Basically, IoT developing is nothing but that is a just think, imagine as a controller, and after that you can send the data on the cloud. It might be AWS, it might be Azure, it might be the any other clouded, UV Trans, Krishna Cloud, or any other clouded. You can send the data, and after that, once it is done, then it will go to the municipality or who is the local administration to collecting all the garbage automated. You will get the reminder, you have to go in these locations, and you can tell, and he will dump this. quite simple. So this is also applications can be a smart hospital monitoring system, and this is it can help this modules to build the better infrastructure of the hospital, because we can't tolerate this any types of dust or might be wastage to be like here and there. So and his needs like a very proper tracking and proper cleanliness of this infrastructure, because this is all about the health sector, right? This also we can make it as one of the model. Street lighting, which obviously this is also the part of one of the smart city. You can use autonomous street lighting system, so we can save the energy. So if there is a no use, no persons, no vehicle in movement is there, then street is automatically like in the dim side, or you can just say that switch off that, and after that this can increase. And even not only the you can do, but even you can control all the street lighting, so you don't need to go like manually do all those things, and you can just do it remotely from anywhere. Supply chain management systems and all those things here. Okay, good. So now the next demo, I want to introduce our colleague Prabhakar Joshi. He is working with me, and he doing lots of R&D projects together, and he also built very nice demonstration. I just want to give some insights of it, how it's work. Then you will understand, because blockchain I did not cover much, because I know that I'm believing that you have already better understanding. But in the case you are not able to get it out, or some terminology you are not able to see, then you can ask in the chat box. I will come back, and again I will give the answers to those questions. Okay, agreed on this point? Perfect. Then let me open now this new slide. This is okay, desktop energy, and this is this demo. Okay, perfect. So objective, what is the objective of this demo is my the colleague showed that he's planning to that how we can make the global trade in the healthcare sectors, right? So if someone needs something, some equipment, some things, or any types of something like part of e-commerce platform, and everything should be like genuine. It should be very transparent. Who is the donor? So no one give like any unethical activities there, and he want to, and every record should be placed in the certain things. So this trade healthcare across the global is exploring the marketplace alongside the decentralized ledger, and secure the healthcare asset and all the transactions, who is the owner, who would send the money, and all everything. This is the flow diagram. I can detail he will give about that brief. So I'm just leaving this part to him. So he will explain like how assets are listed on the web portal, how we can create the smart contract registrations, and all about this in this different tools. With the help of the different tool, he will explain about this. Okay, user initiatives, purchases, like whatever the user want to purchase, MetaMask confirmations, how to create the MetaMask. If you already created the account on the MetaMask, you done something, then that's fine. He will just show the flow, and you can correlate the existing all the theoretical and practical knowledge with this application. Transactions stored and immutable views. So already IoT cloud is one side done, and this in the blockchain side, you will get all the insights how to create the decentralized applications and DApp basically. And after that, once it will done, then we will combine all IoT and DApp. And the next session, we will cover all both together. So how the decentralized marketplaces works is there. So you can see in this is a few transactions is happening, how much is the asset listing metadata, secure login via the metadata, smart contract governance. You can write how to write that one, how to payment gateway, we have to create it, Ethereum, and all the Sequoia records you can get it out. These are the tools stacks. Basically, that is provided like Solidity. They are using this Ethereum. I think already aware about these tools. Only just if you don't know about these tools, and you still not get the chance to do hands-on, then we will keep it little slow, so you can follow up us. But if you already know about this, then we will little bit do fast, so because we have many things to show. So I'm trying to save the time, so I can give more better flavor and different types of tools and demonstration, so you'll get the better idea in this workshop. Okay. So this is the tech stack tool, like I connected the front end, back end through the Ethereum.js, live demo, like buyer purchase with the MetaMask, detail attached, store the transactions, testnet confirmations, public transparency, and everything. So yeah, that's it from right now from my side. Might be my colleague Prabhakar. Are you there? Can you just unmute your mic and make him the panelist so he can quickly share his thoughts behind this demonstration? And in the 10 minutes, might be he can present everything. Yeah. Or I just request to admin, can you make him as a panelist, please? Prabhakar Joshi. Thank you.
He's panelist now, sir. He can.
Okay, perfect. So Prabhakar, hi. Thank you so much for joining. I was just thinking that. So please go ahead. Now it's platform is yours, and please go and deep dive this ledger technologies. Thank you so much.
Yes. Just a brief introduction about myself. First of all, thank you, Krishna sir, for letting me have this opportunity of presenting in front of our esteemed panelists and attendees, everyone. So, hello everyone. I am Prabhakar Joshi from New Delhi, India. I am an augmented reality development intern at Arishna IoT Solutions and also an active open source contributor at Google Summer of Code 2025. My skill sets include Web3 and augmented reality development, along with full stack development as well. And I am proficient in English and Hindi. Furthermore, let's start with our demonstration. I'll just share my screen to proceed. Yes, is my screen visible?
Yes, sir.
Okay, perfect. Let's start by first reviewing the flowchart, which Krishna sir also demonstrated in the call. So, like the whole application is built around the around the around the transparency and the traceability that's missing from the healthcare systems. Talking about the healthcare systems, the exchange of very critical and sensitive medical assets such as transplantable biological materials or specialized equipments. I think you get my phrasing, what I mean by transplantable biological materials. It can be body organs and such, in a legalized way, of course. Now, these transactions require two major things. One being the speed, that is the most necessary. But along with that, it also requires trust, transparency, and accountability as well. And according to the reports we came across, reading through the several news articles and happenings in the world, all around the world, traditional systems uh, that are set in place for managing such high stake transactions lack that traceability factor which we are looking for, and are vulnerable to tampering as well. Where comes our idea? A decentralized marketplace for critical healthcare asset exchange built on the Ethereum blockchain for demonstration purposes right now. Using smart contracts written in Solidity, it leverages MetaMask for wallet integration and Ethers.js to connect the entire thing, like connecting the smart contracts with the ledger as well, with the blockchain ledger that's publicly available. We'll move on with the demonstration first. After that, I'll explain the flowchart because it will give a more it will help everyone in connecting the dots as well. So I'll just start by running the application. Let's just do it in. So in the user opens the project, he is navigated to this page, the welcome page as well. So here the user is also prompted to connect his MetaMask wallet. Now, what is MetaMask? Let's talk about that first. For conventional payments, we have GPay. Let's say for our Indian peers and every one of us use UPI. It can be GPay, it can be PhonePe, it can be Apple Pay as such. But for cryptocurrency payments, we have this MetaMask. It's similar to that, but it's just uh, tailored to act as a middleman in the transactions uh, which require cryptocurrencies. And one specialization it offers is like uh, we can pay anyone from this end of the world to anywhere in the world within a matter of seconds. It won't take even a minute to complete our payments. Let's just log in. I already have set up my account. You can also set up your account by creating just navigating to the MetaMask website and just creating the account there. So let's say I log in here. My wallet is connected now. And okay. Testing on the Ethereum mainnet is one thing, but there is something called testnet in this blockchain. Now, what a testnet is actually, it offers a different environment, test environment for if you want to test some of our pipeline or some architecture which we have developed. So that is what testnet is for. So we aren't trading with real cryptocurrencies here. We aren't trading with real Ethereum here, but it's just a simulation of what the trade would look like if it was done on the mainnet, on the main internet of the Ethereum. So it's just like a different than the original mainnet. So this is my main account, which is connected to the wallet right now. I'll navigate to the second account. It's also my account. That's what these are many of the features that are offered by uh, cryptocurrencies. We can test anything. Like there are no limits when you are working with Web3. So I just enter the wallet address which I want to send the payment to. After that, let's say I want to send 0.01 Ethereum. Here we can attach a keyword picture. For now, let's just go with test and let's enter a message. Let's say this is our message. Can attach a heart symbol as well. Now we can just click on this trade now and we'll be prompted with a alert. Okay. Well, the network fee is very less right now. Let's just go with this then. Right. Okay, perfect. This will go now. Because there is something called gas fees for conventional payments. Like if I'm doing a credit card transaction, banks deduct some fees for the like maintenance charges and all. In the same way, there is something called gas fees here for maintaining the servers, which and all the compensating all the miners that are working continuously towards getting my block to the blockchain. Like this transaction block, for getting this transaction block, this particular block into the blockchain, there is we have to pay some fees to the miners that are doing it continuously, putting their resources to do the work, which is actually a good practice, which we feel. And we'll just complete the payment. Now here, many more transactions from before are listed, and this one is also done, I think. I just reload this page right now. Perfect, it's there. Now it's available on the marketplace as well. And if someone wants to, let's say it was an error, let's say something went wrong, because it's a very sensitive domain and anything can happen in here. So if someone wants to test it, anyone in the world can look on this publicly available ledger. It's the Sepolia ledger from the Etherscan, the Sepolia testnet ledger on the Etherscan website. Now I can view all the transaction history, like what transaction has this wallet address engaged in. We can go through each of these transactions that are available on this blockchain, and it's very tamper-proof. It's immutable. No one can just change the data here, as explained by Krishna sir before as well, when he was explaining how the blocks work and how the block is disbanded from the entire chain if even a single digit from that data is changed. There are certain hash calculations and such and such in the backend, which we won't discuss upon now. But yes, this is the publicly available ledger, and this is the 30 seconds ago transaction, which was initiated on the block number as mentioned here, along with the transaction amount. It's a negligible amount. That's why it's
Might be you can share this link in the chat so everyone can see and go through it, and you can explain, and parallelly he can also see that. Yeah.
Of course, that would be good actually. Okay. I think okay. Yes, yes. Now, any one of you can open this link and just view every transaction that is available on the internet related to this wallet address. Like in our context, we have username @OKICICI. We are just taking very simple examples so that it's easy for everyone to understand. So this is the entire thing. Let's say if something fails, something is not right. If the donor is not, if someone who donated the organ has been forced to do so, taking very worst scenarios, the entire transaction can be traced, and there are ways to even trace this wallet address as well. We can say that there are sayings that crypto transactions can't be traced and all, it's untraceable. But yes, it can be traced to an extent. So that's possible, which provides us safety along with immutability and traceability for every transaction that is concluded on the marketplace and on the blockchain itself. Moving on to the block diagram. Okay, first of all, is everything clear till now? Like whatever we have demonstrated.
Yes, might be you can little bit explore about this, testnet and mainnet, because might be people should not get confused. So whatever you are doing that is on the testnet. So it's not like a legal currency, you can say. This is just like a type of a dummy currency, you can say that. And it's so might be you can give little bit insights on that, so audience will get more clarity on it.
Yes, of course. Okay, let's understand it like this. We all have played Monopoly, I guess, or business. It has different names, the game. So in that we'd have fake currencies in which we'd use to make trade among all the players that are playing the game. And in real world, we have real banks in which we use real currencies to carry out transactions. So just to simulate how the real world works, how the real transactions take place, we have the fake currency in Monopoly. In the same way, just to test out our entire workflow or the pipeline which we have set up for our use case, we can use the testnet instead of the mainnet, because mainnet requires real currency and has significant gas fees. What if I had an idea in mind, I wanted to demonstrate it in front of some investors. So I'd had to acquire some assets and I had to invest some of my own resources into that. And it will be, let's say I'm not fortunate enough to have access to those resources. So it would be a failure from my side because I won't be able to demonstrate my entire proposal at its full potential. That's what testnet offers us. It gives us a simulated environment encapsulated from the real world. It's a different encapsulated environment from the real world scenario. And we can test anything we want in here, just like it would happen in the real world, but just the currency is dummy. It's just a dummy network. It's not the main network. The currency listed here has no real world value. but it's just for testing the pipelines and testing any architectures which we are to come up with. Now, if I want to just launch this application, let's say we want to launch this marketplace in real world scenarios, I'll just have to change the API key from that of a testnet to that of a mainnet. And after the investment I get from the investors, if the project is good enough, we'd have the resources to pay for that as well. So that's a bright side for that, for this project. Okay, is it clear now? Perfect then. If anyone has any questions, we can just discuss it in the chat as well. And let's proceed with the application flow diagram. Furthermore, we'll discover more about the code base. We'll discuss the main functionalities of how the code base is working, how the backend is working, and everything that's taking place behind the scenes. And highlighting one key feature that data phase can be significant and insignificant as well for if we are operating in Web3, working with Web3. Let's start by discussing the basic high-level architecture, how the application is working behind the scenes. So the front end is based upon React and Ethers. React is managing the entire front end, like all the architecture and the UI elements. This card also it's built using TypeScript, and all the base components, all the UI components in the application, they are built on React, along with Tailwind CSS for the designing the components, highlighting this gradient and all. Furthermore, Ethers.js. Now, what is Ethers.js? If I am writing a smart contract, let's first discuss about Solidity. Now, Solidity, like in conventional world, we have contracts. If I were to engage in a transaction with, let's say Krishna sir, we'd make a contract about it. So that contract will act as a proof that yes, we engaged in transactions and I paid Krishna sir, let's say 10 rupees for carrying out the transaction. Now that contract will be a proof of our transaction. In the same way, to carry out a transaction with the blockchain, to ensure become a part of it, to let the blockchain verify our identity and let us plant our blocks upon the entire internet. We need to engage in a similar contract with the blockchain itself. Now that contract is called a smart contract and works on a bunch of rules. If I'm writing a smart contract, I need to ensure some things that the entire content has to be. Now I have to state the licensing, like what will be the license of my will it be an open source contract? Will it be a closed source contract? We can identify it here. Now, if it's based as unlicensed, that means it's a closed source contract. It's not an open source contract. Moving onwards, we have to define a structure of the contract. First of all, we have to define the version of the Solidity which we are going to use. Here I am using anything above 0.8.0. Moving onwards, we have to define a structure of the contract, like give it a structure, like what the contract will be based upon. So here, as we can see, it will have a sender's address, it will have a receiver's address, it will have an amount along with a message and a timestamp. Message as for as we saw here, this is the message which will be listed here, and along with a unique identification keyword as well, which can differ by using several SHA algorithms and all. We can do that as well. Furthermore, after defining the structure and all, we can write functions on what the structure is responsible for doing here, like what this structure has to perform in the entire application. What are the responsibility of this structure? Now, right now, this function add to blockchain, it's responsible. It will collect all the information that's given to it by the user, and it will add it to blockchain. This is the function for that. By structuring it in a specified format, which we have to follow the guidelines of the smart contract as well, because otherwise it will be rejected by the blockchain. Our contract won't be validated by the blockchain, and we won't be able to publish it as well. We won't be able to publish our application on it as well, carry out transactions. So after everything is done, after the input is given and the content is structured in the way it wants it to, the blockchain wants it to be, then the transfer is emitted. Emit transfer, as the name explains, the entire message structure, entire block is being sent to the testnet or the mainnet, wherever we want it to reflect. And after the transfer has been initiated, it's been marked as okay, your block is valid, your contract is valid, and we can proceed with putting you on the blockchain as well, putting your particular transaction on the blockchain as well. Furthermore, we can get all of our transactions that are on the blockchain as well to reflect on our website as well, on our marketplace as well. That way, the out of in the vast internet, in the vast library ledger of this Etherscan, the data is available as well, and our website as well. We can see all the data that is well. For example, this was a transaction that was carried out on 1st March. Let's say I want to view the records for this. So okay, I can go just here and I can view it here as well. So on the website, on our marketplace, we can have only the records we require, and it is available on the internet as well, on the World Wide Web as well. Now, this is how a smart contract works. We are given a set of rules, and we have to abide by those rules when we are writing any smart contract. And to connect this smart contract to our application, we need to leverage something called ethers.js. It is a JavaScript library which is used to connect the Solidity smart contract to our application. After the smart contract is written, it is deployed using this script, the deploy.js, where await functions are also listed here, and if there are any errors, it can be passed as well. And if everything goes as planned, we can just run the main function as well. Okay. Moving on now. Now, we know that we are using Ethers to connect our Solidity smart contract with the blockchain as well as our application. But for connecting with our application, we are fetching such and such data. We are fetching the sender's address, we are fetching the receiver's address, we are fetching the message. Now, what message are we fetching, and how are we fetching that message? For that, we'd have to come to the transaction context.tsx. We'll discuss this in detail as well. But for now, the specific functions, very specific functions which we will be fetching for feeding into the blockchain would be the connect wallet function and the send transaction function, which will add it to the blockchain, which will be responsible for adding the entire stack to the blockchain and getting all transactions to reflect on our website, as we discussed when moving with the smart contract as well. Furthermore, we have discussed the after the content has been passed, it is sent to the smart contract, which is then validated to all the functions that are available, and then it is sent to the blockchain. After everything is validated and everything has been structured in a format that is that we and the blockchain both agree to, the data will be validated, and it will be the miners will be assigned to place our block on the blockchain as well, as to let everyone on the internet view it as well. Okay, moving in more detail, like how the application flow works here. So first of all, when the user enters our application, he is greeted with a main entry point, which is the app.tsx. Now, app.tsx is just a wrapper which wraps the entire application with the transaction provider.tsx, which we will discuss upon. Okay, by TSX, it means a TypeScript. It's just a extension. It's just a more newer version of JavaScript, we can say, in just plain terms. Now the wrapper, what the wrapper wraps? The application is wrapped inside the transaction provider. Now what the transaction provider wraps? It wraps the navbar component, this navigation bar. It's not functional actually right now, but we can further iterate upon it and to our significance. This is the Navbar component. It's for the most of the time it's responsible for the front end features and just as a showcase for all the UI components on our app. Moving onwards, we have a welcome component which serves the purpose of wallet connection. The MetaMask prompt which we stumbled upon when we first opened the application. If we have MetaMask installed as an extension in our browser, it won't give us any notification. It will just tell us to log in into our wallet. But if it's not available there, then we can it will prompt us to install MetaMask in our application as well. We can view it in the code base as well, but it would take up a lot of time. So let's just move with it. So the main use of the welcome component is for the purpose of wallet connection and acting as a main transaction interface. Now, what wallet connection has to provide us with the connect wallet button and all the data which we feed into this field. It will parse it into the transaction context. It's responsible for changing providing the data that it's been fed to into the transaction context.tsx, as to furthermore give it to the smart contract, which will then send it to the blockchain. Now moving onwards, here are the input fields and all. You can furthermore view the PPT. We'll share this document as well by uploading it on a Drive link, which can be viewed by everyone. Furthermore, this is the services component. It's just a part of the front end as well. This part. It's just a emphasis on what we believe and what the blockchain is responsible for, how it is different from the conventional internet and all. Furthermore, we have the transactions component, which is responsible for carrying out the flow of the transaction. Flow of the transaction, we first connect the wallet. User connects their MetaMask wallet. Then the input fields are fed into the wallet, and the transaction data is fetched. After that, the submit is handled in the backend as well, and the entire thing is then sent into the blockchain as well. The transaction, along with that, the transaction cards are mapped, and they are displayed on our website as well. So that's that. Moving on to the footer component, it's just a UI component as well. So only the basic core components of the application are the transaction context for summarizing all the information that it's getting from the welcome.tsx from the available input fields. Oh, sorry, from the transactions.tsx, from all the available input fields, and then send it to the transaction context, which can then feed it to the smart contract, which will then send it to the blockchain. This is the core structure of the application. Now let's discuss what the transaction context is about, what the transaction context is responsible for. Now we'll start with the hero section at first. Now what the hero section is just a core section of our component, this welcome.tsx, which is responsible for showing us the text components and all. Okay, I'll have to navigate into it. Yes, this is just the hero section filled with all the tips and all for giving it a base structure, given our application a base structure. Following that, we have a function that's responsible for connecting the. Okay, yeah, there it is. There is this exact function that lets the user connect their wallet into the application, and if the wallet is not present, if the extension is not present, it prompts the user to install the extension and set up the wallet as well. So if the current account does not exist, this stands for does not. if the current account exists, then the button is prompted to tell to the user that he can connect the wallet. After that, when the wallet is connected, we are prompted with the connection here, and the wallet address is also displayed as well. Moving on to the transaction context now. Now it starts by interfacing a transaction count, like what the transaction number is. In our case, it's we have carried out several transactions beforehand. So the transaction number is instantiated according to that. I think I can show you through the inspect element, like what we are fetching in here. That's all. Yeah, okay. This is the array. This is the entire array. We can instantiate it as a JSON file as well. Yes, this is the entire data, all the data that is being fed into the application. The from address, the to address, the amount of Ethereum that is being transferred, the keyword, the message. We'd have to look into the relevant what we carried out right now. Let's say if we can fetch it as well. Okay, anyways, let's not take up too much time. So after everything is done, everything is passed. After every bit of the data is passed, it is then sent to the transaction context, which then reframes the entire data into a format which can be sent to the blockchain through the active blockchain function. Yes, through this function. It passes the to address as a parameter for as an argument, the passed amount, like what is the amount which we are sending the message for, along with the message and the keyword. And if everything message, voila, our transaction is initiated and it's carried out as well. So this was the we can refer to this for a overall structure of the application, and refer to this flowchart for a more elaborate, more low-level structure of the entire document. I think everyone got the context about the entire application, how the flow is working, how the data is being transferred from one state to another, and coming to the question about why is the database not required in this? Because we are storing every record on a publicly available ledger. The record is being stored on our website through SQLite, but along with that, it's stored here as well on the publicly available ledger as well, as for anyone and everyone to view the transaction details. For a specific use cases as to store the login addresses and all, we can use the database, but it would work as fine as it's working now if we were to store the transaction details and instantiate the ledger upon click as well. Because why let a centralized party manage all the details, all the transaction details? If it was being monitored by us, okay, we have a dummy data for that as well. Yes, if it was being managed by us, by our team, let's say by a centralized authority, we can just change any of the available records here. We can just change the wallet address here as well. Let's say I change the amount to 0.1 to 1 and just save it. And when I just open it, open our application here, yes, this record has been tampered now. So why let a centralized authority manage all the records of the transactions and all, when it can all be available on the blockchain itself? Now, if I were to open it in the testnet, I can see on the centralized ledger, okay, this is a transaction of 1 Ethereum. So, but I did a transaction of a very less amount than this for carrying out the transaction. So that we can validate by viewing it here in the ledger as well. We'd have to go over many of the available records, but yes, we can do that. It's possible. That's the significance of blockchain. I explained through a demonstration. Now, any questions regarding this?
Okay, yeah, great. It's a really very, thank you, Prabhakar. It's really well explained and very detailed explained about that, like how the things is working, all the structure of the blockchain, like JavaScript, TypeScript, front end, back end, and Ethereum chains, whatever we are using that. And this will really help you to the understand the next level of the applications, because I know that there is too many informations today. We are talking about cloud, we are talking about the hardwares, we are talking about Python scripts, we are talking about the JavaScript, we are talking about the TypeScript, and many more languages, and Solidity, obviously one of them, right? So yeah, there is a lots of information. So the thing is like is all are connected. So this all tools will help you to create the one solution provided with the help of IoT and the blockchain. So obviously it's not like a single day practice or 2 days practice. We are providing the platform, we are setting the mindset. So how to start such type of applications. I will also share few of the real-time projects that are currently going on, and our team is working on it. So what are the current challenges we are facing, what type of project like industry is looking for, and all in the next session. So but meanwhile, if you have any questions, any doubts, then you can ask me here, and we are happy to help you. I think one question I got that is very interesting. In India, MetaMask payment system is allowed to use? Then answer is it's allowed to use, but like not officially announced that, like cryptocurrency is our currency, the like a regular currency of the India. It's like it's your own risk if you are using that, and it is quite controversial, and there is a lot, but there is no official statement by the government of India that cryptocurrency is acceptable or something like that. So I hope that you got that. But you can use it, you can trade it, you can do whatever you want. There is no something like someone will call to you. Okay. Second, like I share the link of ThinkSpeak Cloud, means might be in the break time. What you can do is you can, if you are interested, then you can create the cloud. And we are also have a system here. So if like it is possible, I will get the time. Then I will ask for one volunteer, and they can come. They can send their API keys and all. I will show that how it's work. Like I can flash these things. If you have you are interested, then I can show and how it's work actually. So into the application you can understand. So those we will do it practice together, and we will build some applications together also in the next sessions. So any questions? Like we are it is because we have also running out of time. We have 5 to 10 minutes. So I would like to like discuss more about that. If you have any issues related that understanding about cryptocurrency, if you have any problem with the Solidity, any coding steps you are not able to understand, then please let me know. So we are happy to give the guidance. Any questions? So shall we move, or you need a little break or something? Or so just like I will take 5 minutes time then more, and after that I can give the break then. So because I have to just show a few things, and so you can set up your minds for the next sessions, and you can just prepare yourself, and then again we'll be back. Waiting for the answers.
Okay, sir. So I think we can take a break for 10 minutes. So we can meet again at 3:50 or 4 as per your wish.
Yeah, that's great idea actually. So yeah, because already I know that there is a lots of technology terminologies is binding in your mind. So just I think it's a good idea to be take small break, and again we'll be come with the new energy, and we will again start all the connections between the blockchain, IoT, and all the sensor steps. Okay, then thank you so much.
Okay, sir.
Yes, thank you guys.